Okay, let's talk about ratios and proportions. Now, these are probably like the most important thing we'll do in this course, especially for every trade. And it doesn't matter which one you're doing, you're going to use ratios and proportions in some form or fashion. Okay. Now, as you can see, I have written down here a ratio. Do not forget this definition. A ratio is just a comparison of two amounts. Now, I know there can be triple ratios. But in this case, we're just going to deal with double ratios, okay? But don't lose sight of that comparison, okay? A ratio is just a comparison. So and there's three ways you can express ratios, okay? So like say your ratio was 4 to 1. So the way they can say this, they could say 4 to 1, and that could be 4 parts something to 1 part this. The other way they can express this, now remember these are all equal, is 4:1, or the way we're going to use it, 4/1. Okay, so like if they said the ratio of cats to dogs, was like 4 to 3, it's like you got, let's say, four cats to 3 dogs, and this is in the middle of a story problem. That would translate to 4/3, and I know with this one, 4 would be cats and 3 would be dogs. Okay, I know it comes after, cats comes after the 4 and 3 comes after the dogs, but sometimes they'll say cats to dogs and like 4 to 3. Okay, but we need to have this skill for the story problems we're going to look at later. Okay. Now, setting up these ratios is pretty simple. Most people don't have trouble with this. They just kind of forget that either 4 to 1 or 4:1 means this, okay? Where the real challenge in these ensues is when you have proportions. So I have that written down here. Let me get that up on the screen. So a proportion is just 2 equal ratios, okay? And what we use to solve proportions is something called the cross product rule. Okay, it's a really, really helpful rule in math. Okay, you can use this in anything. I mean, we'll use this for percentages too when we get to that. So the cross product rule states that if you have A over B and this equals C over D, where A, B, C, and D represent any real number. Okay, this is probably like the most mathy I'll get the entire quarter. So what the cross product rule states is you think cross. This is what they mean by cross. Product, well, that's a result of multiplication. So what that means is if I do A times D, I call it the shoelace method. A times D will equal, you do C times B, which mathematically, right, BC, always alphabetical, equals B times C. So basically, if you do this times this, and that times that, they have to equal each other. If they don't, you can't put an equal sign between these. So I'll give you a really quick example of that. Like say we had the fraction 1/2 equals, we know this will equal 5/10. Well, if I do 1 times 10, that's 10. 5 times 2 is also 10. Okay, so the cross product rule works. But what we're going to use this for is when you have unknown amounts, okay, solving proportions, because it'd be nice if it was just this simple, but it won't be that simple. Okay, so let me give you an example here. Like let's say we had x over 4 equals 12 over 16. Okay, now I know with this one, most people can probably look at that and know what the answer is. Some people look at this one and they see like, okay, to get from 16 to 4, I divide by 4. To get from 12, do the same thing for 12, and I get the answer, okay? But that won't work for all the numbers we're going to deal with, because we're going to deal with some pretty weird numbers. So you need a method that's like a solve all, okay? And just so you know, the solving method I'm about to show you, it does not change for the rest of this chapter, okay? It'll be the same. So what we do is we apply the cross product rule. I do 12 times 4, which is 48. I do x times 16, which is 16x. Oops. Write that again. 16x. Okay, now for those who remember your algebra, this is a pretty simple step. If you don't quite understand the algebra behind this, that's completely fine. We'll get into this more in later modules. So we look at this one. 16x means 16 times x. So to undo this multiplication, I use division. And what you do to one side, you do to the other. That is the golden rule of algebra. Cross these out. Oops, I don't know why my thing made a triangle there. Probably recognize the shape. Let's see, so that leaves me with x, and then 48 divided by 16 is 3. Okay, so then we got our answer algebraic here, 3, and if we want to check this with the cross product rule, which is always a good thing to do, is check. You don't have to, but just kind of see how this stuff all ties together. 3 times 16 is 48, and 12 times 4 is also 48. Okay, so oops, put the equal sign in there. Equals. Okay, so that means this is the correct answer. Okay, now you'll see a bunch of different problems that kind of masquerade like they're something different, but it's just the same thing in a different package. It just kind of depends, how they write it. But overall, it's not anything difficult. The good thing about this is the solving method does not change. It stays the same. You always cross multiply and divide. You just have to adapt to the numbers that are there. Let me give you another example. Like, let's say we had 6 over n equals 15 over 10. Now we look at this one. I'll draw a line here. Now we look at this one. Same thing. We're trying to find the amount that makes this true. The n's just on the bottom, okay, but you still do the same thing. You do 6 times 10, which is 60, 15 times n. Okay, 15 times n, you just write that as 15n. Okay, then we divide by 15. So you can see, you can be kind of robotic about this. If you don't quite understand all the math that goes into it right now, not the end of the world, okay? Just if you want to keep it as simple as this times this divided by the third amount, that's fine. So we do 15 divided by 60, which is 4. Okay, and if you want to check that, you can put the 4 in here. 15 times 4 gives me 60. 6 times 10 gives me 60, so it works. But again, like if this algebraic method's a little bit too much to digest, it's like, oh my God, I don't know what he's saying. He's throwing in all these terms. All of a sudden, we were just doing basic stuff. Now we're thrust into algebra. If you just want to do this times this divided by the third one, that's fine. Okay, or like this one, it'd be this times this divided by the third one. It's the same thing. I'm just showing you this for stuff we do later on down the road. Okay, let's do one more example here. Because sometimes people think when the numbers change, the method changes, and that is not true. Okay, oops, let me just get some more screen here. Okay, so let's say we had 12 over e equals 0.4 over 1.0, 0.4 over 1.5. Okay, so with this one, you're dealing with decimals here, and people say, oh my God, decimals, I don't know what to do. We've only done whole numbers. It must be something different. No, the method is still the same. You still cross multiply and divide. So you take 12 times 1.5, which gives you 18. You do 0.4 times e, which is 0.4 e, and then we just divide by 0.4. Okay. So it's just, again, it's just keep it in context with the problems you're doing. So we get E equals, I think that's 45. I'll use my calculator to make sure I'm right on that. What was it? Let's move this over. So we did 18 divided by 0.4. Yeah, 45. Okay. Shouldn't have doubted myself. So we get our answer of 45. Okay, and again, if you want to plug this in and check it, you can. You don't have to. Okay, so but when you look at all three of the examples together, it's a lot of rinse and repeat. It's a lot of, just cross multiply and divide. Okay, so that's the good thing about this method compared to or these problems in this section compared to the other ones we've done, is it's going to be really, really repetitive solving wise. And as you'll see with the story problems, it's just a matter of getting everything in the right spot. But once you get to here, it should be run of the mill. Okay.